Hi guys, today's video will be about dealing with multiple cash flows. So the objective today is to, using examples, explain the processes involved when dealing with multiple cash flows. So there are generally two types of multiple cash flows. So you have the future value type and the present value type. So we're going to be firstly dealing with the future value type. So the future value with multiple cash flows, an example I've given is if Alex had $2,000 in his bank account to begin with and then deposited $100 at the end of the first year, $250 at the end of the second year, and then withdrew $200 at the end of the third year, what would be in Alex's balance after the fourth year if the savings account paid interest of 8% compounded half yearly? Okay, so first what we do is in step one, we write down the information you have and then you construct a timeline with that. So we have the principal equals to 2,000. The rate is, the quoted is 8% divided by 2, which is the number of compound period per year. That gives us 0.04 as the compounded interest rate per period. And then N will change depending on on the time of investment, okay? So if we construct our timeline, it would be, we'd have $2,000 in the beginning, okay? We have a deposit of $100, and then at the end of the year 2, we deposit another $250. At the end of the year 3, we withdraw $200, and then at the end of the year 4, we want to know what we have here, okay? So we want to know the account balance at this date. So what do? Well, we can do future value, so find the future value. To do that, we'd have to bring everything into terms of future value at date 4, okay? So again, if we just put that into our timeline, so $2,000 we begin with, we have an increase of $100 by deposit, another $250 deposit, minus $200 from withdrawal, and now we want to find this amount. So all we do, again, find the future value at this date, okay? Now to determine the account balance, we must determine the net future value of all cash flows, including the principal amount, okay? So including this amount, we want to find the account balance, we must find the future value of each amount. So in step 2, we find the future value of the principal amount, because a lot of people forget this. So I just made sure that we remember to determine the future value of the principal amount if we're determining the account balance. So this will be the base from which we add or subtract from. Okay, so we start off with the principal amount and then find the future of that in 4 years' time. So if you can see here, we have to compound it by 4 whole years. So from year 0 to 1, from 1 to 2, from 2 to 3, and 3 to 4. So 4 whole years of compounding, that's what we need to do. So then if we put this into our future value equation, that would just be $2,000, 1 plus, we know the rate is 0.04, and then the number of periods is, we have 4 years times the number of compounding, which is every half year, so therefore we have 8 compound periods altogether, and that should give us a value of $2,737 and about 14 cents, okay? So that's what the principal amount would be worth in 4 years' time. So then in step 3, that's when we have to calculate the impact of variations in the principal amount. So for all the other inflows and outflows that occur, we're just going to find the net change in the principal amount, okay? So to do that, we'll just start off with the 100 deposit at the end of the first year. So if we go to our timeline, we realize that there's only 3 years of compounding that this $100 deposit received. So from first year to second year, from second year to third year, and from third year to fourth year, that's only 3 years of compounding that it receives. So therefore, the future value formula for that would be 100, 1 plus the rate per period times 3 years multiplied by the number of compounding per year. All right, so that would give us a future value of $126.53 about, okay? So then we go to cash flow 2. So there's a $250 deposit at the end of the second year. So again, if we go to our timeline, at the second year, we only receive 2 years of compounding. That's from year 2 to 3 and from year 3 to 4, okay? So therefore, in total, there's only 4 periods of compounding. So that's 2 years times by the number of compounded per year, which is 2. So that gives us 4, all right? So therefore, the future value equation would look like this. So it'd be 250, 1 plus 0.04, 2 years times the number of compounding per year, that's 2. And that should give us a value of $292 and about 47 cents, something like that. And then lastly, we move on to cash flow number 3. So that's the 200 withdrawal at the end of the third year. So remember, we need to make sure that we get the sign right. Because it's a withdrawal, it's a minus figure, but again, we use the formula as we normally do. So if we look here, from year 3 to year 4, there's only 1 year of compounding that it receives. So as a result, our formula would look like this. So 1 year of compounding times the number of compounds per year, that's 2, and that should give us a value of minus $216.32. Alrighty. So then after that, all we need to do is find out the total or the net change or variation. So the net effect is of the deposit, there's an increase by $126. Another increase by 292, and then that's at year 1, that's at year 2, and then at year 3 we have a deposit. So that we have a withdrawal, so that minuses from the net amount. So therefore we have a net increase in the principal amount or the account balance by $202.68 about. So once we have that number, we just add that on. So add any net increases or decreases onto the future value of the principal amount, and therefore we get this value. So at the end of 4 years, the account balance would be $2,939 and about 82 cents. Okay, so that's just the future value multiple cash flow scenario. So now we move on to the present value with multiple cash flows. So for example, Alexis is planning 2 separate snow trips. She knows she will spend $1,000 in the first year and another $500 in the second year. So how much should she put in her bank account now to exactly cover her holidays in both years? And if we already know that the interest rate is 12% compounded monthly. So first, again, step 1, we write down the information we have and then we draw a timeline with it. So we know the thing that we're looking for is the principal amount that we invest now. We know the quoted rate is 0.12. There's 12 compounding periods per year. So therefore we have a rate, an interest rate, a compound interest rate per month of 0.01. And then we also know that n varies depending on what time the cash flows occur. So right now we want to know when P, so that's the X amount that we don't know. And we know there's a $1,000 withdrawal here and a $500 withdrawal here. So if we just change this time into months, the year would be 12. So 12 months. And 1.5 would just be 18 months, just to make it simpler for us, okay? So then if we translate that over, we have P minus 1,000 minus 500, and what we're trying to do is discount everything back to here so we know the principal amount that we need to put into our bank account so that by the end of year 1.5 or in 18 months time, we'll have a zero balance, okay? So our principal investment here should offset both these withdrawals, okay? So again, step 2, find the present value of the principal amount. So the present value of the principal amount is unknown and is therefore X. So it's equal to the present value of net outflows, since we are calculating when P plus the present value of variations equals 0, and therefore our account balance is 0. In step 3, we calculate the impact of variations in the principal amount, okay? So we'll start off with a $1,000 outflow in the first year. So if you notice here, in our timeline, there's only 1 year of compounding or 1 year of discounting that it receives. As a result, that's 12 months of discounting. So we put 1,000 here, 1 plus we know the rate is 0.1 and then 12, okay? And therefore, we should get a value of around, that. Make sure it's always negative so that we know that it's withdrawal, it's taking them out now. So it's minus $887.45, okay? So then if we move on to cash flow number 2, there's a $200 outflow, a $500 outflow, and the amount of discounting is 1.5 years back to the present value at time 0. So what we need to do is discount by 18 months, okay? There's 18 months, so again, put the future value on top, 1 plus 0.01, 18 months, all right? And that will give us a value of, again, we have to do the minus, just to make sure that we get the withdrawal right, all right? So then after that, we add any net increases and subtract any net decreases. So we want to find when the present value, or P, plus the present value of variations that we have here. So minus 887.45 and minus 418.01 equal to 0 when our account balance completely offsets the actual transactions in the future. So then all we need to do is just use some algebra. So just x minus, that's the net decrease or the net outflow that will occur in present value terms, and therefore if we want to offset it, all we do is move it to this side, change the sign of it, and then we'll therefore get x equals to $1,305.46. So we conclude by saying Alexis would need to put in $1,305.46 into her bank account now to pay for both her trips in the future without putting or depositing any more money and completely offsetting those ski trips. Okay, so that's the end of the video today, guys. I hope you learned something. Thank you.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.